So, one of the most intuitive ideas in the human psyche is that objects in nature tend towards sphericality. And this is rather tempting to believe since it appears to us that in nature, all objects, or most objects, most celestial bodies, seem to be spherical. You know, stars are spherical, moons are spherical, the earth is spherical, and so on. I think we think of particles as really being little spheres. We can see atoms under electron microscopes, and we know for certain that they're pretty spherical. You know, they tend towards sphericality, and for most of our science and most of our history, or really what predates our science, uh, if you look at the Aristotelian models of cosmology, we think in terms, or we were thinking in terms of heavenly spheres rotating above us, and the Earth was in the center of that universe. The Sun had its own sphere, the Sun sphere, I guess, um, in which the Sun would rotate around the Earth. Likewise, there was the lunar sphere for the Moon. There was the Jovian sphere for Jupiter, the Saturnine sphere for Saturn, and so on and so forth. And there were two stars also in the night sky thought to be, I think, it was Hesperus and Phosphorus back then, the morning star and the evening star, as opposed to what it later became known as, which is the planet Venus, which is the same object. It just appears in the evening and in the morning, and then disappears for a certain number of hours and appears again in the morning, right? So yeah, it's tempting to think of nature doing this. It's tempting to think of nature as being something that tends towards being perfectly rounded, or quite rounded, or spherical, or the objects move in circles in space, which isn't true. They move in ellipses, and it's also untrue that most things in nature are circles because they're actually not, or spheres. They're not. They're very slightly egg-shaped. Most things in nature, and this is actually interesting because the ancient Greeks believed that the universe was the shape of an egg. Interestingly, so the Greeks knew about this. They knew about this very slight eccentricity in the objects in our universe, and we can see this down to the subatomic level now. We know that electrons, particles themselves, are actually not spherical. They're very slightly egg shaped, which is very weird. And the fact that we see this phenomena, and we don't understand yet, I don't think quite, the emergent phenomena associated with this phenomena, but we see this basic tendency towards oblate spheroidness, or egg shapedness, or pear shapedness, or whatever you want to call it, at every level of nature. If you look at galaxy clusters, a galaxy cluster won't be a perfect sphere. It'll be something spherical-ish, but not spherical. Likewise, it's because I suppose what it must come down to is that in the universe there's a general force of gravitation that is pulling on everything else. So but the implication of that is that there's more gravity in one direction, surely, than there is in another. So I think as we start to get more attuned to thinking in terms of cosmological gravitational influences on celestial bodies, we can start thinking more about using celestial bodies themselves perhaps as gravitational instruments, or to see, the effects of gravity at cosmological scales affecting individual bodies, say gas giants or planet Earth, which is not spherical. It's slightly egg-shaped. It's the southern hemisphere is actually larger than the northern hemisphere by area, as I understand it. So on the bottom, we're slightly bottom heavy. It's yeah, egg shaped slightly. Yeah, it's very very interesting. I think, is an idea, this. And it's very interesting to see it played out at every scale we observe in nature, and that's very cool, I think. So yeah, no circles, no spheres in nature. Nature seems to abhor symmetry, i.e., in the geometric sense, in which we use the term symmetry. It seems to abhor even distributions and balance, and actually homogeneity, I think, to some extent. But then again, if you zoom out to the even larger scale, I'm sure it is homogeneous again. So just to say something's homogeneous, to have this cosmological principle that it's homogeneous and isotropic. So you'll find inhomogeneities and anisotropies in, say, the cosmic microwave background and the matter distribution in the universe. But if you zoom out more, it's just like, well, it is homogeneous and isotropic again, and you can keep doing that and making that infinite regress, I reckon, until it proves that yes, it is homogeneous and isotropic, depending on how you look at it. Right, right. Well, yeah, I guess that is a principle in science, isn't it? It's something that doesn't stand a chance of being incorrect, but it's almost a bit trivial, is it not? Never mind. Thank you for watching, everyone. Bye bye. Love you lots.